Hello everybody, I'm Miss Veena Kautekar from Speak NNC. On behalf of Speak team and Nana Saheb Madi College of Engineering, welcome our Executive Director Professor Mahesh Doshi sir, our Principal Professor A. Mirze sir, and our today's speaker Mr. Nagesh Karamali sir, SR Manager, Department of Computer Science Engineering at IIT Bombay. Also, I welcome our program coordinator, Professor A.P. Dhamangaonkar sir, and all dear enthusiasts. We all are known about today's title, ESIM and Arduino on Cloud. It's my great pleasure to introduce our speaker today, who is going to talk about the same. Sir is a SR manager in Department of CSE at IIT Bombay and heads the Fundamental Research Group. His broad research areas are in the field of parallel databases, big data analysis, adaptive recommendation system, peer evaluation system, etc. His interest also lies in category theory, control theory, system dynamics, music theory, and many more. So now, without making much delay, we will now move to our session. So I request Mr. Nagesh sir to start the session.
Hello, thank you so much. Thank you for introducing. Let me share my screen first. So, is my screen visible? Yes. So, is my screen visible now, Pawan? Okay. So visible, right? Okay. Yeah. Thank you. So let me start this session. Okay. Now. Okay. So the session is on ESIM and Arduino on cloud. So this is not just a session that I will not just speak about ESIM and Arduino on cloud, but I would like to speak something more, maybe what collaboration is possible and how it can be achieved. So it's my great pleasure to give this talk at Nana Saheb Mahadik College of Engineering, Sangli. So these are the two systems that we have today. These two systems were built during lockdown. So in a period of 2 months, I will show you the demo. I'll show you the internal working and the architecture and other things. So this system is actually fairly complex. So the first system, ESIM on cloud. So these are the features. So it has got analog circuit design. User can simulate. There are components which the user can actually drag and drop, connect them, and they can put some parameters. Based on the parameters, it will simulate. So I'll show you a demo later on. There are other things. So people from electrical would understand what is netlist. Netlist is nothing but set of components and their connections, right? So it's a very simple way to represent a graph. When you come to computer science, we look at it as a graph. But when you go to electrical, it's a network. So these are the simulations which are offered: DC solver, DC sweep, transient analysis, AC analysis. Electrical people would be knowing them. They must have already handled such things. The source is it's an open source code, GPL version 3. One important thing, nice thing, is that this was developed during lockdown by only 4 people, 4 interns. We call them fellows, but they are interns actually. They worked full time for 2 months. I mean, less than 2 months probably, yeah. So I will actually give a demo. Okay, so I generally suppose there is no internet connection, and so I have the demo right here, but then I will give a live demo now. So let me take you to ESIM on cloud. So it looks something like this. The initial screen that you saw is something like this, and then I'll show you one simple example. So this is your circuit, right? You see that they are connected. I'm taking it from the gallery because I did not waste time. Otherwise you can drag and drop as you want, so you can drag and drop, right? And I can delete them, right? So I can drag and drop from the various components which are available. Okay, so we have around maybe 2000 components already here, which you can see, right? So I'm just going slow because maybe there is some network delay, so that you can compensate, right? So there are thousands of components, as you can see. They are all imported here, right? So and then they are all available on the web, and then you can build a circuit with something like this. So this is an bipolar amplifier circuit, and if you see, every transistor is having a model. So this model is actually a standard model for various types of transistors. So for example, BC4468 that you see here, right? So these are the parameters for that transistor. Generally, a transistor, when we represent in this, we have represented in this system that you see, this transistor is actually does not have a model. Now if you want to say that this transistor is having a model, a particular model, so you should be able to say that thousands of transistors you should be able to simulate, right? So likewise you have resistor here with certain values you can change, right? Capacitors, right? So you can see this 10 microfarad capacitor here. You can put more parameters, probably a model, right? So you can go at any level, right? So if you want a very basic capacitor, then it is like C1, and then just 10 micro, 100 micro, or things like that. But if you want more parameters to put, then it should take those also. So even the sources which are there, so you will find, okay, there are certain values which are put, right? So this is a standard sine wave, right? So which I will show you how it corresponds to a final chart. So let me simulate it. I'll go for transient analysis. This is just for demonstration. So let me say 100 milliseconds. This is a stop time, and then I have step time, right? So I want to simulate it now. So I would get something like this, right? So so what we are doing is that we are having an output for each and every nodes. So let me show you something which is important. Yes. Yeah. So if you see that this is, so if you see, I think there is some problem here. It should show me a very good sine wave. No, it is not showing me a sine wave. Yeah, there is some problem. Let me do it. So I'm just doing it again. I don't know what is the problem. It would generally show me a sine wave. Okay, yeah, okay. So this is an amplified one. If you see that this is amplified and this is the original one. So by looking at the circuit, I mean, if you draw a circuit, if you analyze it, your intuition would be to say that the signal will be amplified, but this tool allows you to see something, so that you can correct, you can change, right? Look for certain points where what signal is going, right? So all of this can be analyzed, right? Okay, so let me go to our slides. Um, so another tool is Arduino Cloud. So here also it's almost the same that you would see, but here you have an Arduino Uno, and then you have other components which you will try to connect and come up with some interesting circuits, right? So other things which are there are ERC checks, and you have a code editor where you will actually write the code, right? And then you want to say, I want to put this code right in the Arduino Uno, right? And then something is going to happen, right, based on what circuitry you're done. So this was done by two fussy people. I mean, two fellows interns, I would say, working during lockdown for 2 months. Okay, this is very interesting. I will show you the working of it. So by the way, both are equally interesting, but I found that people like Arduino more than ESIM. This is my observation. I've given this talk many times. Uh, okay, so let me take you to Arduino on cloud, something like this, right? And then you can go to the gallery, right? So I'm showing you something which is already done. So there are four types. So one is visual, that you see. So there is a Arduino board, and there is a 7-segment display, and now they are connected, right? So you can connect using, these are the wires. Almost the same philosophy that you see, the same components. Then you have controllers, input, output, and some sources. So here the components are less. There are the components in eSIM, there are many. So we have a code editor also. It's already filled up code, right? So what it does, it's going to count, right? So it's going to run as a counter. So the code is actually, I mean, the user can write down the code. Maybe I'll just show you. So it's something like this. So it's a normal code editor where it will give you options, and then you will be able to write it, right? And it will help you in your syntax. So let me run this and show you. So it is counting, right? So this is one demonstration of the visual. It's showing something visually. Let me take you to some other one which will be a buzzer, right? So it's going to sound, right? So here also you'll find the same code, right? The code is different for this and that based on the application. And let me run it. I hope you can hear the beep. Let me stop it. Yeah. Then I would like to show something about probably a gas sensor, right? So here also you have code. So there is a gas. You see a gas here. So there are values. So there are values which are coming. So if I keep it closer, I should get a good value, right? No, it's still not getting. Yes, you see the values have changed, right? So anyway, these are all calibrations. So how far, what distance, and so that depends on the practical applications of it. Of course, those also can be incorporated, right? Today everything is possible. So at least at this point, somebody can build something like a gas sensor, and if there is a smoke somewhere and some fire alarm or kind of thing is possible, right? These are simple applications. So let me take you to maybe something rotating, right? So here also you will have code, right? Code is there everywhere. So you see something, it's rotating. So we have seen four different types. One is visual, sound, then something to do with the gas, and I mean the proximity sensors, and the motor. Okay, so let me take you back to the slides. So I've already shown you the demo. Let me speak about the overall flow. So I'm giving you one flow that is for the eSIM. I'm not going to speak about the Arduino. Much of the things are the same. So what happens is we have lib files which are standard ones. So what happens when you do research, you figure out what is available, which one to pick, and those are the files which we took, and they were from KiCad. Actually, KiCad many of you might have already used, right? So those files, so we don't, you see, the purpose is to not deviate from the standards and still achieve something in practice, right? If you deviate from the standards, then your tool may be not usable after 2 years, 3 years down the line. So what we do is that we extract some information, right? There's a pin information, and draw the components in a SVG form. Okay, we chose to put the pin information SVG. Okay, these are all implementation details, doesn't matter. And then we have a parser, and then you have a schematic grid that I showed you, right? The schematic grid can actually generate the netlist. I did not show you that the netlists which were generated. Probably I would have, maybe if I have time I will do that. And then at the back end we use something which is already standard, which is ngSpice, right? So everything is an open source here, so there is nothing commercial. So ngSpice is a simulator, it's a mixed mode simulator. Okay, we are using them. We are using ngSpice and other components, and then we parse. It's like a table form, and then we take the table in the front end, and then we display the graph. That's what we do. And then you see that there are some parameters which can be supplied to the grid, component parameters and the simulation parameters which were shown to you. So it's a fairly complex system. So before the lockdown, we had almost 2 months. We tried to see what components could come in the system, and see, I'm from computer science department, so I'm not from electrical. But anyway, so when you have to solve some problem in some other area, you have to learn something. So today's world is multidisciplinary, right? Mostly multidisciplinary or interdisciplinary. You should not be happy only with computer science, right? So you should extend yourself. So I tried doing that. So we studied initially, and then we came up with a model. So how we can have, what components will be placed where, and who is going to access, and what is going to get displayed, what libraries are going to be used, and what simulators. So this is what was done. And then we said, okay, we have now 6 interns, right? So they are in second year or third year of their education, engineering education, a BTech program or a BE program. Okay, not postgrad level or whatever. So common people like us, right? Who have built a system. And we tried introducing scalable architecture at the back end, so that so your architecture has to scale. Say for example, if I have 50,000 users and all of them want to simulate, right? So how is it possible? So what we have is we have Dockers. We also have at the back end a queuing mechanism. So that means any request which is coming, okay, is going to go in a queue. Okay, so you're not going to lose it, right? So the user finally has to see that if I have executed something on my computer, I should get the same response, at least to some extent, by executing on a web-based system, because web-based system is used by thousands and millions of people. But I should not have that time delay, right? So I should not get my simulation after 2 days, right? So we need to scale at the back, and that is also very important, right? Just building a system is not important. You have to look at other things also, right? So this is essentially, I'm trying to say that it's a real project where many things were involved. much involved. I mean, so we also use, I mean, extensively use GitHub. I believe everybody must be using GitHub, right? And that is your recognition today. So today I did not give them a certificate saying that they have worked for me or or this institute. They can just show their GitHub repository, or they can just show LinkedIn. Okay, so they have worked here, they have contributed here. Everything is automated, so you don't need certificates, or you don't need any letter from anybody. So if you have done some project, it's all visible. And of course we have Discord chats. I mean, I will show you where how nicely we have used this also. So I mean, when developers, or maybe researchers, developers, programmers, all of them have to communicate, there has to be a channel. We found WhatsApp was not good enough. I'll show you why, and then you will realize. So WhatsApp generally has, you can make just one group and not more than that, right? I mean, just you can make multiple groups, but then they are all different groups. So, or you have to include all of them at different places. So in Discord you actually have channels, right? There are multiple channels. I can go to this channel, that channel, this channel, and I can see, so I'll show you the glimpse of it. And then you have code review, merging. We have a code running on Git, running on CI/CD pipeline automatically. It's checking for your code. It's saying your code is not standard. Okay, so do you know you have to follow some standards. See, all of this becomes very important when you want to deliver a software which is production grade, right? So merging becomes easy, right? So when you work in a team, you understand all of these things, where everybody has got their responsibility. Somebody is doing this, somebody is doing that, and then some two people are saying, my file is interfering. I'm sorry, interfering with somebody else's file. We have to find out what to do with that, right? So you fail first, right? So then you merge, rather than you merge everything and then you fail at the end. So here we say that, struggle and figure out what is the best way to do it, and then the best code will go in the main server, right? So all software principles, all software development principles, whatever probably you might be teaching or learning, is all here, right? So when you actually do a project, you do understand. Otherwise, I heard many people saying software engineering is like, oh, it's just a theory. But how do we convert that theory to practice, right? So these are very important. So let me give you the architecture. So we have, as I showed you, I mean, the lib files, library files are nothing but, maybe I can show you. I mean, I have some time, I believe. So let me KiCad files, file format. Yeah. Today it is very easy to search. So let me take that liberty. I'll show you a file, a simple file. It's something like this. Okay, so how is this file created? This is created by thousands and millions of people. So there are some 20,000 files like this for that component, different types of components. So these files are created by thousands and millions of people around the world, and this is all in collaboration. So this is also in open content, open source. So we have used these lib files, right? So they are nothing but they just tell you what is connected where, and there is a format which is available. Anybody can learn and do something with it, right? So here you'll see one component here, another component here, all of them are from the same family and things like that. So pretty standard, nothing, no rocket science, everything is available. Only thing is that you have to go and hunt for it and study them, right? So nothing is difficult. I'll show you my So this is our repo, where you can see you if you when you visit, you will get to see the demos are also placed here. I mean, you can see how things are working. Somebody wants to install, they can actually take it and put it on their machine. You put it on your university server, you can access it, it's all free of cost, right? And this is the stack, right? So, and then you have I'm sorry, and then you have documentation. Okay, so if you go here, there's a huge documentation, at least enough documentation where you can go and search for yourself. So you don't need a teacher, you don't need anybody to so maybe to mentor at a different level. Okay, this is just to know things. So, and there is a chat. Okay, so I'm not connected here. So I will show you, and these are the tools which we are using. You can see some linting, passing, and all that stuff. You can, yeah. So these are all that you will see, and these are highly automated. I mean, many of the things are automated. You don't have to. You can see the code factor. Oh, there is some problem with this is an external service which we are using. I don't know why the Microsoft is down. Since the time Microsoft has overtaken GitHub, there is some problem or the other. Okay, so let me go to the slides. I would say that let this delivery be not one way, but if somebody has a question, they can just ask that question. Okay, I think I would love to have something like that. I mean, which will interest me a lot. So this is the architecture that I actually showed you. So you have Arduino compiler at the back end. You have Redis and Celery. These are meant for queuing, so that you can queue the responses, requests, and everything which is done at the back end, right? So thousands of such requests can be served, and then you have a models here, which is Django, and you have APIs. Now everything works through an API, right? So you have a simulation front end, which is ESIM and Arduino on cloud. You have block panel, simulation control, which I showed you what is there in the front end. Exactly, I put the same rule checkers. You need to check something, right? So check the rules, electrical rules, and things like that. So those are all here, and then there are block parameters which go to the front end, and then what is drawn is using an MX graph, right? So for Arduino, what we use is we have almost similar, which is rule checker, editor, serial input output. The one which you saw, the values which were coming when there was a cloud, which was, the smoke which was getting closer to the device. So, and then there are something called as eno files. Eno files are the ones which I showed you, which are almost similar to C files. And then you have Rafael.js. This is meant for displaying, the Arduino boards and connections and how it is handled. And then we also have a simulator in the front end. So what happens is that in this case, eSIM, the lib files which are there, they are available in the front end for you. I mean, they are available in the form of some drawing parameters. And then what you have is a connection between the nodes. I mean, nodes in the sense, you have so every device in eSIM is called as a node. I mean, if you understand what is a graph, so it's a node, and then they are all connected, right? And then they are translated to netlist. I can show you that netlist. Why not? Because so for this circuit, you will find there's a ERC check, and then I can generate netlist, right? So this is, so the model which was actually entered, right? So it's all here, and then you see V1, okay, now connected to V1.1 and 0 and with certain characteristics, and C1 is a capacitor connected to C1.1 and V1.1 and 10 microfarad and like that. So this is a netlist, right? And then when you actually enter the simulation parameters, they will all come here towards the end. Now this prepares our circuit file actually for ngspice. So ngspice needs such input, right? So that is the reason why we are converting into a netlist. So whatever is connected, we the information is available here, and then that ngspice takes that circuit. Okay, so let me go to the slides. So the ngspice, actually we send that netlist along with the simulation parameters, okay, to ngspice. Ngspice takes it and converts it, runs it. Okay, so it's a so there is an interpreter there, so it runs it and then it converts into some output that is as required in the simulation parameters that you have specified, right? So that generally mostly it is a table form, right? So this is the input, this is the output, this is the input, this is the output. We take that file and then use the chart to display that file, right? So it's damn simple. Right? Now let me go to Arduino. So Arduino, what we do, we take these eno files, they're all C files, right? We send it to the backend compiler, Arduino compiler. So it compiles into a into an object code, right? We take that the final compiled object code from the Arduino compiler in the front end. We send it to the simulator, okay, which is AVR8JS, and it knows now this AVR8JS. All of them are actually simulators. Okay, if I show you, all of them are actually simulators, but this is a bigger simulator. So now this one is a simulator. This one is also a simulator, but it's a small simulator. This one is also a simulator. Okay, this is a passive, I would call them passive. This is a passive simulator. It doesn't do anything much, just connects wires and things like that. This one is an active. I mean, so what it does is that as the way the code is written and based on what is to be activated, so which signal should go high, right? So that signal will be sent to this one. Now this is also a simulator which accepts that signal. It is waiting for it and then say, oh, something is high, okay, I have to make this one here, and then it will look like 2, 3, 4. So likewise multiple signals are sent, so all of them communicate with each other, right? So this is the way we tried solving this problem, right? I mean, so initially nothing was clear, when we started this. Okay, so we were thinking, how would we do that? Slowly, as knowledge grew, we started exploring many things, and then we had these 6 people, and then everything fell in the correct order, and that is why that is how you see this system today. So most important, I think, collaboration and communication, because I think that is where we lack in communication. Collaboration, generally forget. We don't want to collaborate with anybody. We just want to do everything ourselves. So not a good idea, because somebody might have already done something which I'm doing. So you need not waste time, right? So you need not invent a bulb which was invented by Edison. So you have to know that there is some invention and that is how it is done. So you can carry on forward rather than waste the time there, right? So I showed you this. I mean, you can see the docs passing there, and then you can join our Discord channel. I'll show you some glimpse of it. I have not connected my Discord here, so I will show you not the live one. Maybe if I have time, I'll show you the live one. But I think this may be just enough. If you click on click on here, so you'll find how many people are online and things like that. And this is how our documentation is. So this is a Discord channel. Now you can see we have broken down into, like, ESIM. This is for Arduino. The whole thing is for Arduino. This is for ESIM. we have the docs here, we have ideas. I mean, people can put ideas, people can read the docs, people can read different links sent by different people. And then bugs, somebody is saying somewhere there's a problem, so somebody puts the bugs, they put a request, I mean the file issues on GitHub. Then they come here, they put the bugs here, things like that. So this is how collaboration happens. Enhancement, somebody wants to say, let us look at some enhancement to a component, or some way of maybe an algorithm, right? So one of the things which we have even done is, say a user has actually connected the wires. Now this is an Arduino, and he has not connected in a proper fashion. Then we have a button where we just click, and then the wires fit nicely, right? So this is there you need an algorithm, right? You cannot, I mean, you need some mechanism to do it. So you use all of this, computer science, whatever you learned, applying in electrical, or you need to know something of electrical also to understand what else is happening in the system, right? So I mean, this is very interdisciplinary. And then you have development corner, where people can discuss how development can take place. uh, I'm showing you the screenshots where somebody is posting something, somebody is saying something else, somebody is, you can see how messy it looks when people start developing something, right? But when you see everything finished, it looks so good, right? So I mean, this is very interesting that somewhere the things were like this, and then it has come to a very nice. So you can see how collaboration, through collaboration, so you see different people talking, and talking about different things. Everybody gets something on the table, and then you also feel very good. So after maybe 20 years, even I have learned something from them. So this is very nice. And so this is our, I showed you the old architecture. Now still we have to work, we cannot remain there. Now how do we design something, right, so that it can be used not only by electronic simulation, Arduino, and it can be used by n number of simulators. Like for example, here you can see chemical simulators. You can see open form for civil structural simulations. Then DWSIM, right? The front and down, which I'll just hide this. I'm getting this screen in between. So you can see ESIM there. You can see XCOS. I can show you what is XCOS. We have an XCOS. We have, I mean, we don't have DWSIM, which is a chemical simulator, but there is a DWSIM available on the desktop. We want to port it on the web, right? So I also studied chemistry, in this process, and we have been looking deeply into how to port even chemical simulations, reactions and things like that. So I mean, when you work interdisciplinary, multi areas, you get to know a lot of other things, and then suddenly you feel there is some connection, and which probably there's a puzzle which you want to fit something, and it's working, it's going to work, right? So my way, I mean, looking at it, I wanted to motivate in this fashion rather than just looking at machine learning or data science, or you need something to work on, you need the real data, so today if I have something like this, and I can probably collect a lot of data, right, and then I can analyze, I can do a lot of things. But if I don't have a system, I cannot do anything. I have to work on very fictitious data, which are put up somewhere, and things like that. So idea is to building one application. We are not doing good just for electronics, or we are also doing something great in, I mean, we are trying to do something in architecture, as you see, right? We are also trying to do something in chemical. Building a system allows you to expand, and you have to build such a system where it can be used in multiple areas, right? I think that should be the goal, rather than just build it for one domain or things like that, right? So that's the reason why, say we should have something generic here. right? We draw something generic. So all of this do not come right in the beginning, if you tell right in the beginning, say I want something generic here, I want like this, I want like this. No, it doesn't happen like that. So we have to go in that mess, right? So we have to create something. Once we create something, then we say, okay, let's make it generic, let us see how it is going to work. But while creating also, we have to keep in mind that there has to be some generic level that we address, right? So the roadmap has to be clear, right? I mean, so roadmap generally is available when there's a project running for, say, many years, or at least some months, or many years, right? So that means we have to build something on, which we have to build something which or extend something which is already available, right? I mean, and if something is there in open source, I mean, there's a, yeah, a huge crowd which can join, and you can people can have discussions, collaborations. We can have meetings every week, maybe every 15 days, depends, different types of meetings, right? Somebody can say I want architecture meeting, I want to discuss architecture. Somebody say I want to discuss design. Somebody says I want to discuss the tools used in the system. So why Raphael JS, why this MX graph, why there no other substitute? Okay, so then there is somebody who should be able to figure it out. Though we have figured out in some sense, maybe we are wrong. So probably, such kind of analysis can happen, right? And then we should have the right tools, right? Finally, man is all about building tools. I think the man is the only animal build tools. No other animal on this earth actually builds. Apart from spiders, they build something small, and then that is also nice. But other than, it's very rare to see. So long term goal would be like having a complete EDA tool for VLSI design. So VLSI design, when I say complete EDA tool, I say it's not just about design something and remains on your computer, right? So I design something, I put it on the lithographic process, layout that I would like to show you what tools are already available. So if I have a big board here, right, this is what I want to design. Now if I go drill down more, I will see something here. I drill down more, I will see something here. So this is a hierarchical way of looking at things. And then I go at layer 7 or layer 8 or layer 9, I can do very fine things that are required for that layer, and then go up and see that this is functioning as required, right? So all of these tests are different. If you want to perform some tests at different level, maybe design checks happen here or something like that, right? What I'm saying is that when everything is put in a layout, okay, so layout is something you will see. I mean, these tools are used, by the way, right? People actually design, right? So the people so now this itself is also not enough, what I'm showing you, right? This is magic. What I showed you earlier is shim and magic. There are many tools, okay, so I'll not go into all of them. So I'm trying to give you a glimpse of what is available, and then what if all such tools probably are available as a web base. Okay, magic allows you to do this. This one allows you to actually do hierarchical composition, right? So you understand the importance. So if you have 1 million transistors here, right, how are you going to connect them? And that's not the way, right? I mean, so you look at ICs, then so for example, if I see a computer, okay, what comes in my mind? It's ALU, probably a processor first, right? Processor, then there's a bus, right? Then there are peripheral chips, right? So that is your system box, right? I mean, a computer. But now I want to see what is there in the processor, right? So that's a different level. So in the processor, you say I have an ALU, I have a control unit, I have some bus here, I have cache units and things like that. And then I want to say, I go little deeper. If so what is there? Do I have 32-bit ALU or 64-bit ALU, whatever? right? So and then I go inside, I may have adders, right? And then if I go inside, I will have MOSFETs. They are all connected, how they are connected, right? 1 bit adder can form, I mean, 2 bit adder, 4 bit adders, then make 16 bit adders and things like that. So all hierarchical, you see. So all of these now have to be manufactured somewhere, right? So there is another thing called as a process design layout. So they are called I mean process design kits, and they are called PDKs. Now they tell you actual nanometer level kind of thing, you know. So going from here, once you have a layout, I still need to do something else, right? So in a way, what I'm saying is that, is it possible that a student sitting at home design something, okay, make a chip, and then and that chip goes to the factory just for manufacturing, and then the chip is ready for you, right? So I mean, we should think about all of these things, you know, how easy it could be. But today you see, you have to join a company, and then only you understand what is happening in Intel, right? So you join Motorola, then only you'll understand, right? So why we need all that? So all of this can be done. We don't need to understand some proprietary products, right? So today it's possible that it should be possible to build chips sitting at home, probably a mobile. Then once you build a chip, you know how to build a mobile, then you know how to build better computers, right? So and then there are a lot of research which can go on. So not just building it, but then there could be some research which can fuel into, you know, better designs. I mean, so all of these are possible, right? So let me go back to the slides. So that is the whole VLSI design that I intend to be part of. So Arduino, okay, supporting various boards, components, IoTs, not just supporting, right? So here, what else you would want? I would want to design something sitting at home, probably. Okay, so I want to help somebody who has a power plant problem. It's a water plant problem. Some water plant there somewhere, and there is some problem there, or some monitoring which is required, right? So can I have a system fully designed here, okay, and then once I know it's going to work, now I connect my IoTs. I have an Arduino there, okay, so I connect my IoTs. I have a Wi-Fi or some system, you know, which will send data periodically to the some server, and then I have in front end, I should be able to to do some analysis on that data. Now you can do machine learning, you can do data analytics and many other things, right? So all these things are possible today, and we should aim at doing something of this sort. Now other domains also, like chemical, mechanical, civil, electrical, computer science, physics, biology, medical, right? Everything is possible today. I mean, it's not that you have to go somewhere, and because everything is available, right? So all data is available, everything. So I mean, much of the things are in open source today, and we should use them. So building even machine learning tools, right? Bioinformatics, probably for academics. So we want to probably give some interactive textbooks and with some learning path, so the student don't study everything, you know. Everything is not required. So only more important, okay, so I if I do this, I will be able to do this. If I'm not good at this, I will not be good at this. So, you know, some path, you know, where it covers at least the maximum. So more satisfaction you get when you actually do something rather than just reading. So in some electronic circuit, I used to read when I was a kid. I used to read that circuit, but I never had a chance to actually perform it, right? Or I would have to go to buy some breadboard and connect them. Then only I will, and then but then I still need some other tools like emitter. Then I need an oscilloscope to look at what is happening here and things like that, right? So, I mean, if I have an interactive textbook, right, with simulations built in, and then with some learning path, I think that's more than enough to actually understand what is a bipolar amplifier or some other circuit like that. I need not study more, right? Or if I want maybe theoretically to analyze, I can still work at the device level and put those parameters as I shown you the device parameters, right? So that, I mean, I can still go in theory, I can still be in practice, right? I mean, so all the things should be possible. And of course, if there is a way to auto grade everything, because nobody wants to grade, uh, you know these simulations, it's time consuming, and there should be a way to auto grade them, right? So if student has built something, teacher should come to know, oh, there is it should tell the student first that, okay, there is some problem here. So in our case, how we are solving some problems, not everything, like, if the connection is not there, we'll tell, right? But in a real practical circuit, where you're putting on a breadboard, you will not come to know whether it's connected or not, right? Here at least it tells you something, right? So these are some extra things that can be put in the system, so it becomes useful for grading, final grading of assignment, if at all, if it is to be used in universities at large scale. And building, of course, this all these things cannot happen without having community of diverse contributors. Impossible. I mean, you need different kinds. So we have to search, we have to find. So, people have to be interested in doing something. They come together, discuss. It's not like somebody saying, oh, you do this and this, and this is going to work. No, it's not like that. So any project or any field that you take is always a continuous, involvement. That is very important. And how do we get involved? So I mean, so meetings, then, and then later on coming up with diagrams, they're very important, right? So minutes of the meeting, diagrams, then deliberating it further, all of this becomes very important. It's like, working in a company, right? So today you don't need to work in a company to actually understand all these things. So you can learn by having these diverse contributors at different places. You will learn a lot. And then some mechanism for crowdsourcing activities. I showed you one mechanism where KiCad has used, where these library files were contributed from all over the world. People contributed it. Likewise, such circuitries or such interesting Arduino circuits or electronic circuits or whatever circuits are available should get contributed somewhere, and there should be a crowd, which does that. Interesting crowd. I hear the crowd means somebody who actually understands electronic. For chemical, maybe somebody who understands chemical. So for biology, maybe somebody understanding biology very well, right? So these are different activities, and then, I mean, so they can be fueled in building such a large system, right? So, I mean this can, this has a potential to go to millions and billions of people, right? I mean, you can take this to even school level tomorrow, and then create animations probably, or simulating some, core important things which they find it very difficult, or use it across the curriculum. I mean, if you have something generic if you have built something generic, I mean, that can be used anywhere, right? So maybe not very generic, but at least to some level, to covering, say engineering areas, at least civil, mechanicals, and things like that, And so how can we contribute, right? So of course, domain expertise. Somebody understands electronics very well. Good. Of course, then research is also important. Just understanding is not important. So I'll come to that, why where we should be going. So product design. Somebody is good in designing a product. A front end, of course, even a front end is, I mean, that's great enough. I mean, somebody giving such inputs. Performance engineering. I spoke about one aspect of it, which is scaling in the cloud. So there could be many other things. There are many others, and we should, that there are people who actually work on performance. They can use this system and probably design, find an alternate way to see the architecture. Of course, system architecting itself, then designing, automating, testing. I mean, so much of the time when students say that I want to code, they don't do one thing, that is, they don't test anything. I'm sorry, because this is what I have seen, but I will stress more that here, because coding is 20%. coding is 20% or 15%. Okay, remaining 85% is everything, right? So if you don't write a good document, nobody is going to see that. So writing a document is also very important. Even drawing diagrams is also very important. All of this make your project success. Otherwise, it's only code, and there is no other paraphernalia that is needed. I mean, if you believe in that, then it's not going to work. So coding, testing. I mean, testing is nothing but, here we talk about automated testing. That means you have to write code, right? So coding does not mean just mean coding, it also means testing, it also means lot of other things, right, which are important. So even DevOps, like setting up dockers at the back end. I mean, if you don't know how to set up I mean, it is not very difficult. All these things are available, and they can be learned in 1 or 2 days. Even Django can be learned in 1 or 2 days. So you have to pick one tool. No, that we have chosen Django, we have chosen Dockers, right? Things like that. So, and then process design, software. You learn software engineering in school. I mean, this colleges. But then, how do you apply it? How do you see whether it is working really? I mean, this is a very challenging area, right? And then writing, of course, I said very important. All of this, and there are more. I have not. I didn't want to clutter. I had many more other points which I didn't want to clutter the screen. So why work on this project? Open source, open content, everything is available. Collaborate. You don't even need me, I would say. Okay, but it is good to know somebody and discuss, because if I know you, then I know what you are doing, and then we discuss. It happens like that. But if you work independently, I work independently, I don't know what you're doing. Yeah, you don't know what I am doing. So there is no information. So I believe in collaboration. Why? Because you alone contributing, it's never has happened. I mean, for last 2000 years or more, I think somebody is contributing alone is very very rare. Means he has to be a grade or something like that. So to contribute to the society, you have to take views from everybody, and then only contribution becomes visible. And then building teams. I mean, so why? I mean, so today age is, I mean, you have to solve problems which are, so you see our water problems, everywhere, you'll find. I hope you also have some problems. So many people think that going to US means they will solve problems, but those problems are very different. But in our country there are problems here itself, so you are not solving those problems. And what problem you can solve? I mean, what problems? So problems are here, right? So more problems you will get here, and not going somewhere in some other country. So I'm saying that because I generally see people here, speaking in that fashion, because you have problems here, and then you don't want to address, and you say I want to go to US and then only I'll solve problem. How is it possible? So that means your mind is not conditioned. It is not going to happen automatically. Right. And here we are saying apply theory in practice. You can see, you can open your textbook and then do this, and then you will come to know. You may find bug, and that is also very good, that okay, something is not working. I mean, when I started doing the demo, it did not work, right? It's good, now we know that there is some problem. If everything is working, then there is no problem, and there is no work, right? So there has to be some work. So apply this theory in practice, understand. Okay, so and then I would say multidisciplinary, as I mentioned, is a very important thing. It is not enough to say that I am a computer science grad. I need to be well versed even in bio, just to understand what is how do I apply my things in in biomedical, in bioinformatics. I mean, if I don't understand genes and all these things, today the research for COVID-19 would have been possible if we had all these tools online, right? All bioinformatics tools available. Somebody would have done research in online would have been possible. And then going to lab and figuring out whether really it is happening. See, we have to think much farther away. rather than I just say bio and then computer science. But we have to COVID is actually a good it's a panacea that is making everybody think. And of course the evolutionary cannot be just build something and you say I want to start something, oh it's going to look like this and like this and like that, and it is going to be this way only. It doesn't work like that. You have to build something which doesn't make sense, and then keep on building, and one day it will make sense. But then not alone, with collaboration. People also tell you, oh okay, do like this, maybe we should do this way. And then creativity and innovation, and you will find innovation right here. So you don't have to actually visit industry or anywhere. You visit industry, that is much better. But what if it is possible that you can do innovation being at home, being in college? I mean, that's the kind of atmosphere that creativity and innovation is kind of atmosphere that is required. And then some professional recognition. Sorry, I said GitHub and LinkedIn. I mean, you don't need CV also today. You say, somebody says I want your experience, or professional experience. So some people say GitHub, LinkedIn. There's no other thing required, right? So there only you will find that somebody is referring you. Somebody is saying he has done this, he has done that, oh he has done exceptionally in this. So recommendations are coming there itself, right? So today the world is changing. So even now, so I use LinkedIn very less, but GitHub, of course. But now if I have to give recommendations, I have to give on LinkedIn, right? So because the students will ask, you have to write something about me on LinkedIn. Okay, so I have to also learn, right? So all these are very important, and we have to keep on changing. This is what we should be aiming for. So at the moment, how can you teach and learn? So I would say you can use such tools in the course, right? Experiment with it. You can install it in your own servers, whatever. Though we have it, but we have a limited bandwidth here, limited space. uh, and then so your course projects, I mean, generally in IIT you will find every course is having a project. Is a small project or big project, there is a project. Even for first years, CS 101, I remember when Professor Fatak taught CS 101. He said, so I was his course associate. So he said that I want my students, CS 101, first year students, first semester students, I want my students to do fingerprint recognition. You understand? Aadhaar fingerprint recognition. So he went and he got some 10 devices. He distributed among 600 students. All of them formed some 20 devices or something. So some 10 or 20, I don't remember, but there were around 600 students odd, and many of them wanted to do some fingerprint recognition in the first semester. To my surprise, at the end of that semester, within a period of it was a 1.5 months kind of a project. Okay, so for that course, the computer programming course, I don't know whether you call it CS 101 or computer programming. I will say it's computer programming. First year, first semester course. To my surprise, when I saw towards the end, they were demonstrating how fingerprint recognition works. Wow. So what did they do? They learned. They went on. So though we also gave them some resources, they went and implemented those algorithms. Some of them went and got libraries and then used those libraries to do fingerprint recognition. They were able to do. Some of them were. I mean, things were not okay, but but they learned a lot. I mean, you can expect what is possible even from a first semester student. So that's why I'm saying. So here, software design, whatever design we have today, if you take this further, because I am, see, this project is cross domain, you see, multidisciplinary, right? So that means a lot of help is possible from different domains. So that is why I'm trying to get this in the limelight. So here you can do software design. If you are teaching design, oops, object oriented programming, you can actually design, and you can see where our design fails. Okay, so this is one way to do research, right? Architecture, how some people who actually do research in architecture, they can actually look at the system or various other system. I mean, generally research happens like this only. You don't have to evaluate one of the best ones which are already there, right? So it is not exactly like that. So you have to match apples with apples and oranges with oranges, right? So architecture, then coding, implementing, right? Somebody can take this and build I mean, go ahead in building something concrete EDA tool, like using magic X shim, which I showed you, right? So writing research announcement, somebody can actually make a proposal, right? So I mean, the lot of possibility, so see this, I mean, this is a whole, I mean, this project is actually a research project, I would say. And then in practice, what you see is what somebody will get satisfaction, that I am able to learn better than what I did before, right? And then generalizing to various simulation tools in different domains. So that means now you have to involve all faculty from all discipline, all students. Okay, so if I want something in mechanical, if I want something in civil, then I need domain expertise from everywhere, right? From civil, mechanical, electrical, everywhere, right? So only interested people can come forward and have such participation, and then think of building something. See, leaders are there. It is not that they are all hidden somewhere, so you only have to keep the ball rolling always, and then you will find somebody. Even if you get one or two people, one student, two student from one college, I mean, that is also great. I mean, just one or two, but if the whole college wants to do something like this, I mean, they can start building. I mean, lot of possibility. I mean, you can get help from us. I mean, we can get you started. Finally, what I want to say is that this is what I believe, and of course, everybody in the educational technology would also agree with me. So if at the lower level you just remember things, if you remember things is not enough. So if I just remember what is the processor, what is the bus, and what is the ALU, is not enough. Above that, I have to understand something more about it, how they interface and what happens with them. Now, can I apply means, can I make a circuit somewhere and things like that, right? So that is still okay, but can I create something different? Or, I mean, I'm not talking of out of the making castles in the air and things like that, but can I create something? So today, this project that you see, the creation, right? So I believe that you have to work at this level, right? Analyze, evaluate, create, and not you have to know this. It is not that this is not required. This is required, but more emphasis should not be here. Understanding, remembering, more emphasis it should be in analyzing, evaluating, and then creating something out of it. It's a puzzle, and you have to get one from here, combine and create something great, right? So this is the spirit in which I would like, I'm trying to motivate all of you here, including faculty and students. I believe there are some faculty also here, and of course there are students. And let us build things together, because without togetherness, it is not possible. So this is what I wanted to say. And of course these are our GitHub. You can, so this is also important, right? bit.ly cloud simulation. So how easy it is for a user to just remember this, right? I mean, so when people do marketing, brochures and all that, so they do it in such a way that it is understandable, right? So I've tried to cover as much as possible from different angle, and as you can see, and so this is our information. Any questions? I will share my slides with you. You can I will give it to Pawan and Aniket. So let me take some questions. Um, Hello, hi. Is there a delay on YouTube or
Yes, sir.
something? Yeah, hi. So I have
Yeah.
finished my talk. I think I have taken around 1 hour and 13 minutes. I
Okay,
hope it
sir.
is okay.
We will just give gratings, and if anyone have doubt, we will continue with it, or we can stop here.
Yeah, but I want to hear doubts because
Yes, sir.
without doubts we cannot stay.
Yes, sir. I will ask. Hello, everyone. But if anyone have any doubt, please let us know. Just write in the comment box if anyone
Okay.
have any doubt.
Yeah, comments. Yeah.
I think, sir, students have no doubts.
Okay.
So
So approximately how many students were there?
actually, sir, if we will end, then we will get actual count. Now I
Ah,
request to the Mangaonkar sir, please, I will
yes,
add them
yes,
here.
Yeah. Am I audible to all of you?
yes, yes. Go ahead.
Okay. Nagesh, it was a really wonderful session. And
I
yeah, it
tried.
was really wonderful session. No, it was a really wonderful session. I just wanted to ask you that if some electrical students and electronic students, if they want to perform their projects, like they are using right now MATLAB as a for the simulation for their last year projects. So
Hmm.
I would like to insist them in this particular year that they
Hmm.
will use the whatever the platform you have developed and your team
Hmm.
has developed.
Hmm.
So
So
just I would like to request you to share some stuff and links how to access and how to use it.
yes, yes, I am sharing with you
Yeah.
the presentation fully, and towards the end,
Okay.
there are all the links. Okay, so in
Yes.
case
Okay.
they have a
Okay.
trouble, so I can help them. That's not a problem. So I also
Okay.
would like to know what kind of simulations they will do and whether our tool will be useful. If not done, somebody will
Yes.
have to build something. That is a nice
Yes.
thing. Yeah, yeah,
Right. Because
right,
there are so many power electronic devices which we want and we are always simulating, just like
right.
a buck boost converter or something like that. So
Hmm.
if they can, instead of MATLAB, if they will use this particular software, we can
Right.
find out some flaws also, and we can find out some good things also rather than bad. So that can
So
be also, that might be possible.
yeah, so I would say
Yeah.
we should have a mixture of electronics and computer science, not just
Right.
electronics. Because
Yeah.
electronics
Right.
people will
And
actually say yes or no. Now,
yeah.
if it is no, then how somebody can take it further?
Yes. Yes.
Understand?
That's right.
And there has to be some discussion because
Yeah.
there has to be some sort of a meeting. You can organize. We can do it even on Saturdays. See, people who are interested, they can do it even on Saturday, Sunday. I know them, not just on the weekdays. Yeah, but you will have to find such interesting people. Ah,
Sir, there is one doubt in the comment. I will show
yeah, yeah,
here.
yeah. Yes, 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 yes. Yes, I saw that. Is it possible to add more development boards like Arduino? Yes, yes, yes. It is possible. So if somebody has to make it, then has to add it. Then you have to write a simulator. Okay, simulator for that is a JavaScript simulator in the front end, and then at the back end you have to see whether such a board is supported. Okay, whether the compilation in that object code is possible. Yeah, because we have used Uno, and I believe there are at least 7-8 boards which are possible. You can take any one of them. And so yeah, so if the boards are not supported, then it has to be made supported, right? So that means such requests can be raised and things like that. Everything is possible. Okay, so it's not that only time will tell, how much things can be done. Yes, Pavan.
So can we stop here?
Okay, if there is any other question, no. So okay, fine. So
Okay, sir.
and give me
Veena
the
will greetings you. I'll
yeah, yeah.
just wait.
So
Thank
here
you so
I,
much.
on belief of all the participants, assure you that we will grab your all saying, sir. The session was very much helpful and informative. So I, on behalf of Speak team and the entire organization and youths as well, extend a hearty vote of thanks to respected Nagesh sir for gracing your important work and sharing with us your findings and opinions today. Thank you for giving us your precious time, sir. Also, very much thanks to Professor A.P. Damangaonkar sir for introducing all of us with such a great personality and being with us with youth support. Thank you, folks, for your cooperation. Thank you all, and hereby I declare that our session is successfully concluded.
Thank you so much.